Access to a container registry works best when it follows the same identity patterns that you use across the rest of your environment. So it's important to understand the main authentication models for Azure Container Registry, how roles shape what users and services can do, and how to build a clean access plan before your first deployment. Identity decisions should come first because they determine how authentication and authorization behave across your registry. You see, the identity model, which is individual accounts, service principals, or even managed identities, they all define how people and automation interact with your registry. Once that model is clear, the sign in method becomes a simple implementation of that detail. Starting with identity helps you to avoid mixing ad hoc credentials, it reduces long term security risk, and it keeps access predictable as the registry grows. Now, most environments rely on a small set of identity patterns that cover both human and automated access. Individual logins are used when developers or operators need to pull or push images interactively. This model ties actions to a real person, which improves auditing and accountability. Service principals work well for pipelines and other types of automation that need predictable credentials. They support role assignments and secret rotation, making them a strong fit for most build systems. And managed identities remove the need for stored secrets at all and are ideal for Azure services like ACI, AKS, or Azure Functions that all need to pull images. They simplify authentication and they reduce operational overhead. And the admin user provides a simple username and password for compatibility scenarios, but it's not designed for long-term or shared production use. Now, registry roles can define what an identity can do once it is authenticated, so they should match the intended operation. This is where you start setting up the authorization. First, pull-only roles allow identities to retrieve images without being able to modify anything. This is the safest option for runtimes that only need to consume images. Push-capable roles allow publishing of new images or updating tags and managing repositories. These roles should be limited to build systems or trusted operators. And import operations require permissions to bring images from external registries into ACR. This access is usually reserved for automation or administrators who manage image sourcing. Now, scoping access correctly helps to keep the registry secure and easier to govern. Assigning roles at the registry level gives broad access. This is sometimes necessary for build systems, but it should be used sparingly. Scoping access to a single repository in the registry limits what an identity can touch. This is ideal for teams that own specific applications or services. And using separate identities for pipelines, imports, and deployments keeps permissions clean and makes auditing easier. And any identity that uses secrets needs a rotation plan so that the credentials don't become long-lived risks. And of course, regular reviews can help remove unused identities and confirm that permissions still match the workload's needs. Now, let's go back to that admin user for a second. The admin user exists only for convenience. It should never become the default access method. The admin user is helpful when testing a new registry, troubleshooting connectivity, or working with tools that don't support Azure Identity. And because the admin user is a shared credential with broad permissions, it doesn't support auditing or least privilege. Relying on it in production scenarios creates long-term security and governance problems. And finally, planning access before pushing the first image can help keep the registry secure and predictable. So the first step is to identify the actor. Decide whether the actor is a person, a pipeline, or a runtime service. Then you clarify whether that actor needs to pull, push, import, or manage the images. And based on that, you're going to choose the narrowest scope that still supports the required operation. This is called least privilege. Then pick the identity model, whether that's an Entra login, service principal, managed identity, or that admin user, all based on the actor and the operation that they want to perform. And if secrets are involved, define how they're going to be stored, how they're going to be rotated, and how they're going to be protected. And lastly, test the identity by performing the intended operation to confirm that permissions and authentication behave as you expect them to. Ultimately, a clean access model for Azure Container Registry starts with identity, assigns roles based on intent, and scopes permissions tightly. With a clear plan in place, you can support development, automation, and runtime services without sacrificing security or maintainability.